Okay, so now is it clear? Now is it clear? Yes, okay, so hello, hi, a very happy good evening. Yes, Keshav, thank you so much for joining my lecture. So please do like, share and subscribe. So today we are in lecture 2 of breathing and exchange of gas. So our motive is not to complete the chapter or rush away with the syllabus, but our motive is to understand the concept clearly. So today I'm going to teach important definitions that comes under this chapter. So you have your breathing capacities and your respiratory capacities and respiratory volumes, right? So we're going to talk about that in detail. So if we finish the chapter, well and good. So otherwise I have one more session where we're going to discuss important questions from this chapter. So there we will finish the chapter. Alright? Yes? Yes, Pooja, hello, hi. So thank you so much for joining my lecture today. So please do like, share and subscribe. Okay, so before we move forward with your respiratory capacities and volume, so I have an announcement to make. So tomorrow at 4 p.m. so we are talking about molecular basis of inheritance. So we are talking about the topic translation and human genome project, that is HGP. So join me for the 4 o'clock session tomorrow, and tomorrow at 6 p.m. I have a motivational session for you. So it is entitled Good Things Take Time to Happen. So please join me for both the sessions tomorrow. So I'm looking forward to an interesting session with you guys, okay? And I hope I won't disappoint you. So once again, so this is my announcement for crash course. So we are conducting a crash course in English medium for 45 days. So please join. Ma'am Pooja in one group topped quiz with 97 out of 100 in human physio. That is fantastic. So great, Pooja. So many congratulations. Very good. So please maintain the same. So always be strong in your concept. Okay, and thank you, Keshav, for sharing the information with me. So this crash course is for 1999 and you have all the 3 subjects, that is physics, chemistry and bio. So please think about it. So all those who are going to enroll, please enroll quickly before the offer changes, and then don't tell me, ma'am, the offer price is gone, because that's why in every class I am letting you know, because this is pretty high, I understand, but this is affordable, right, for all the 3 subjects and for 45 days, right? So this is perfectly worth it. So please join. Alright, yes, hello, hi, very happy good evening, Antonia B. So thank you so much for joining my lecture. So please do like, share and subscribe. So shall we move forward with the lecture today? Yes, so lecture 2 of breathing and exchange of gas. Okay, so we were discussing all these, right? So yesterday we defined what is breathing. So we spoke about the respiratory organs. So we spoke about the mechanism of breathing, that is inspiration and expiration. So today we'll talk about some important definitions, and then we'll move forward with exchange of gases and transport of gases. Alright? Yes? Okay, so here we go. A quick recap of your respiratory passage. Yes, can you give me the respiratory passage? Where it starts and where it ends? Quick? Okay, so you take in atmospheric air in your nostrils. Yes? Okay, just give me a minute. Yes, so it starts in your nostrils. Yes, Pooja, absolutely right. Then it moves in through your nasal chamber. Then it moves further. So you have your pharynx. So this is the common passage. So then you have larynx. So this is where you have the vocal cords. So this is known as the voice box, right? So moving further, yes, Shimpi, hello, hi Dharni, a very happy good evening. So thank you guys for joining my lecture. So please do like, share and subscribe. Yes, Shimpi, I'm fine, thank you. I hope you are doing good. So please take care of your health. So then it moves into the windpipe, that is trachea, right? So trachea is also known as the windpipe, and the opening of trachea is known as glottis. This is covered by a cartilaginous flap like this. So this is your epiglottis. So this prevents the passage of food inside your windpipe. So this is your trachea, right? So your trachea is a long or thin bone, right, that runs in front of the esophagus. So this is surrounded by incomplete cartilaginous rings. So you have 16 to 20 incomplete cartilaginous rings that is present, okay? So after trachea, it opens into the bronchi, the primary, the right and the left bronchi. So this is the primary bronchi. So then this opens into bronchioles, and then this further opens into your alveoli. Right, so this is your respiratory passage. Yes, Pooja, it's absolutely right. So your bronchi, your bronchiole and your alveoli makes up your lungs. Right, so your trachea opens into the bronchi at the 5th thoracic vertebrae. Yes, clear? Okay. So now your lungs is situated in a region that is known as thoracic region, because you have your thoracic vertebrae there. So it is known as the thoracic cavity is where your lungs are situated. So your lungs are surrounded by double membrane. So the membrane is known as the pleural membrane. Okay, and in between these two, it is filled with your pleural fluid. So this is the design of your respiratory system. Okay, your human respiratory system is divided into two parts. The first part is your conducting part. The next part is your exchange part. So which is your conducting part among this? So your nostrils till your bronchi, it is your conducting part. Okay, so they help in carrying the oxygen from the atmospheric air into the alveoli. So alveoli is the actual site of exchange. Okay, so only alveoli forms your exchange part. Yes, okay. Okay, so hello Shubham sir. Yes, a very happy good evening. So thank you so much for joining my lecture. So please do like, share and subscribe. So yes, hello, Vyat. Okay, so how do I pronounce? I'm not really clear. Okay, so Vyat. Okay, so NTA tells like they're going to conduct NEET on September 5th. How can I revise the whole chapter in 5 days and practice your crash course and practice mock? Your crash course will complete on September. No, my crash course is for 45 days. So NTA said they're going to conduct exam on September 5th. So don't worry. So we have planned for 45 days. So this course is starting from July 5th. Okay. So my crash course will not end before September 10. But if suppose we get a notification that NEET is going to happen on 5th of September, so we will finish it off way before. We will finish it by 20th August. So in a day you will have 2 lectures. So in that way we will complete. Yes, we have a backup plan as well. So yes, now you're getting scared. How do I revise? How do I revise? That's why I said please don't waste any time in between. It is still fine. It is still fine. Don't worry. So if you join the crash course, so before you join the crash course, revise the chapter. So you still have time, right? So crash course is from 15th of July. So today it is 6th. You still have 9 days time. So start revising this chapter. So in crash, when I show you the slide, you should know everything. So I will give you last minute tips in crash, and the questions that appear in the exercise sheet of crash you should be able to solve without any mistake. So start revising. Don't wait till the crash course starts. Start revising right now. So how will you revise? So your Bible here is your NCERT, okay? So this is not official, so because I have not gone through it, just because Vyat is asking me, I'm explaining it. So please go through your NCERT thoroughly. So please go through my slides, all the questions that I have discussed, and try explaining yourself what you have understood. Okay, yes Bhuvana, hello, a very happy good evening. Thank you so much for joining my lecture. So please do like, share and subscribe. But in my opinion, I don't think they will conduct it on September 5th because it is not a school exam. So where you have to organize only 2,000, 3,000 kids, because you have to organize lakhs of kids. You have to spread the word, people have to work in with the application, you have to get your hall ticket, you have to do corrections in your hall ticket. So it's a lot of procedure. So I don't think, so if suppose your exam is going to happen on 5th of September, so they should have at least given some clue about the change in the date, right? So they, as of now, they have not done anything. So I don't know. So it can be true what you're saying, but in my opinion, they would not have before 15th of September. So that is why we very casually plan the crash course, alright. Yes, even in case if there is a sudden change, if there is a sudden change in the exam date, yes, we have a backup plan with us, so don't worry. So we will complete all the chapters in your crash course, so that is a guarantee. From bio, yes, I am prepared. Even if your exam is much before, I know how to finish the syllabus and I know how to give it on time and fingertips. Okay, so don't worry. Yes, good evening, Swami. A very, very happy good evening. So thank you so much for joining my lecture today. So please do like, share and subscribe. Yes, this is the conducting part and this is the exchange part, right? Okay, so now how does the exchange of gas happens? Okay, directly it went here. So how does the exchange happen? So here we talk about on the blackboard. So how does this exchange happen? So here we go. So first, atmospheric oxygen enters inside your nostrils, right? So it directly goes through your trachea and then into your alveoli. So from alveoli it moves into the bloodstream and from the blood into the tissues. And tissues utilize this oxygen to produce your ATP. So in this by process you produce carbon dioxide. So the carbon dioxide takes the same route in the reverse direction. So you release out carbon dioxide. So first what happens? So oxygen enters inside your trachea. So your oxygen from the atmosphere is exchanged in the trachea. So here you have the first diffusion. Right, the second diffusion is between alveoli and bloodstream and the third diffusion is between your blood and tissues. So this is how the process of exchange of gases happen. So exchange of gases happen through simple diffusion. Clear? Yes? Fine. So this is one part. So now how does the mechanism of breathing happen? So how come I have only one slide? Okay. So how does the mechanism of breathing happen? Because we have two set of process, right? So breathing or respiration includes two processes. So what are the process? So one is inspiration. The other one is expiration. Right? So this is the process by which you take in oxygen. Right, and this is the process by which you push out carbon dioxide from your body. So how does these two happen? How does, yes Bhuvana, hello, hi, yes I acknowledged your wish, yes hello. So how does these two process happen? With the help of a gradient. So these are happening by the process of simple diffusion. So diffusion is movement from a higher concentration to a lower concentration, meaning there is a difference in concentration, right? So this is known as a gradient. So here I have a pressure gradient which ensures that the inspiration and expiration process happens, okay? So here I have a pressure gradient. So what is the pressure gradient? So here we go. For the process of inspiration, so oxygen comes inside, right? So during your inspiration, the pressure inside your lungs, so the pressure inside your lungs is known as intrapulmonary pressure. So during inspiration, the pressure inside your lungs is less than the atmospheric pressure. So you know, for the diffusion process, it moves from higher concentration to lower concentration. So here which is high? Atmospheric pressure is high. So the movement of air is from the atmosphere, thus oxygen enters inside your lungs. So this is the process of inspiration. Okay, the next one is the process of expiration. So during the process of expiration, the gas moves outside your body. So meaning carbon dioxide is expelled out, right? So in this case, the pressure inside the lungs, which is your intrapulmonary pressure, right? So this is greater than the atmospheric pressure. So which means the movement is like this. So carbon dioxide is expelled out. So what enhances this process, or who is the main player in inspiration and expiration, is your ribs, your diaphragm and a set of muscles known as internal intercostal muscles and external intercostal muscles. Okay, so they play a very important role. Done? Yes, so this is the first part. So now, how does these players act? So first let's talk about inspiration process. So first, for inspiration, your diaphragm contracts. Okay, so when your diaphragm contracts, meaning your diaphragm is a flat bone like this, right? It's a flat curve. Okay, ma'am, what is the use of lungs? So lungs is where your exchange of gas happens. So from the lungs, it has to go to all your body parts, right? So lungs help in this transfer, right? So this is your diaphragm. So when it contracts, the thoracic volume increases. So what is the thoracic cavity? The cavity where your lungs are located. Okay, so that is your thoracic cavity. So now your thoracic volume increases. All right, so when your thoracic volume increases, your ribs and your sternum. So sternum is where your ribs are connected on the dorsal side, so they are lifted up. So they become a bit activated. So when this happened, so then your pulmonary volume increases. So when your pulmonary volume increases, right, so your pressure decreases, because pressure and volume are always inversely proportional. So the intrapulmonary pressure decreases. So when the intrapulmonary pressure decreases, so what happens? So pressure inside the lungs is less. So from the atmosphere, it moves inside the lungs. So oxygen comes inside. So this is how your process of inspiration starts. Okay, so next one is expiration. So expiration starts with the relaxation of your diaphragm. So there your diaphragm contracts, here your diaphragm relaxes. Okay, done? Okay. So the next step, here your thoracic volume increases. So thoracic volume increases. So here your thoracic volume decreases. Done? So here the ribs and the sternum lift up, but here the ribs and the sternum return to their normal position. They return to their normal position. So here the pulmonary volume increases. So here the pulmonary volume decreases. So when volume decreases, so pressure increases, right? So when the pressure inside the lungs increases, gas moves inside the lungs. Okay? Gas moves inside the lungs. So gas moves from the lungs to the outside. So Shimpi, listen. So here I told you. So when the pressure inside the lungs is less, because it is diffusion process, right? So gas moves from the higher concentration to lower concentration, and here the gradient is pressure. So when I write like this, the atmosphere has more pressure. So the gas from the atmosphere moves inside. So oxygen moves inside. This is your inspiration. Okay, so meaning the pressure inside the lungs is less compared to your atmospheric pressure. Okay, so here I said the pressure inside the lungs is high compared to the atmosphere. So the gas inside the lungs moves out. So meaning carbon dioxide moves out. Okay, so this is expiration, this is inspiration. Now this part is clear, Shimpi and Bhuvana? So this part is clear? Yes? So can I go to the next one? So this is the general formula, but how it happens in detail? So who are the players for this gradient? Ribs, diaphragm and your intercostal muscles, right? So here I am saying for the process of inspiration, your diaphragm contracts, So the volume increases. When volume increases, pressure decreases. So always remember, volume and pressure are inversely proportional. So how do you correlate this? So if I put 100 people in a small room, so there's a lot of pressure, right? So everyone is pushing and pulling. But if I put 10 people in a big hall, pressure decreases, volume is more. So always volume and pressure are inversely proportional. So understand, for inspiration you are trying to inhale. So gas from the atmosphere should come inside. So the pressure in the atmosphere is more. So the pressure inside the lungs should be less. So when the pressure is less, the volume should be more. So here the volume is more, so the pressure is less, so what gas comes inside. So right opposite is your expiration. But you should remember, here diaphragm contracts, here it relaxes, okay. So that is the simplest thing. So here in expiration, we are going to give out carbon dioxide. So the pressure inside the lungs should be high, so the volume inside the lungs is less. So when the pulmonary volume is less, the thoracic volume will also be less, right, because you are putting it inside. So your thoracic cavity is what houses your lungs, right? So it is much in the same way, okay? So if I put a box inside a box, if I compress the bigger box, the smaller box also gets compressed, right? But if I blow more air inside the smaller balloon and the bigger balloon, both the balloon increases. So it is much the same way. This is your inspiration and this is your expiration. Alright, yes, clear? Okay, so this is what we discussed in yesterday's lecture. So coming to today's topic, so today we are going to discuss respiratory volume and capacity. So this has always been a myth for people. So they do not know how to calculate, they do not know which is what. So try to understand. So you have 4 volumes and you have 5 capacities. So in total you have 9 definitions. So what is volume and what is capacity? So tell me this basic thing. So we have been learning this term of volume and capacity since we are in 8th standard. At least in maths we came about the term of volume, right? Then what is capacity, right? So what is capacity? So suppose, how do I explain these two terms for you? So I have a beaker, right? So I am adding 250 ml water. I am adding 250 ml water inside the beaker. So this 250 ml is my volume, the amount that I am adding. But actually this capacity of the beaker is 1 liter. But I am adding only 250 ml, right? So this is the volume that is accommodated inside the vessel, but actually the capacity is that the beaker is designed to hold 1 liter. So capacity is the total ability of the vessel or the beaker to hold water, okay? But volume is how much I wish to add, how much during the circumstance I am using it, okay? Yes, perfectly explained. So Bora also explained it properly. Anthony also explained it properly. Yes, capacity means ability and it is to store something. Alright, okay. So this is the difference. So now first we are going to deal with volume. How much we can add the volume. So here I gave the example of water. So since here it is breathing and exchange, so here we are going to talk about the volume of air, the volume of gas, okay, of carbon dioxide and oxygen. So we have 4 volume definitions and 5 capacity definitions, okay. So what are the definitions? The first one is tidal volume, the normal volume. All of us breathe, yes? Are you breathing right now? Yes. So if you have a dog or cat next to you, so is that breathing? Of course, right? Everything is living, so all of us are breathing, you, me, everyone. So every second we breathe, right? It is not that we breathe after every 5 minutes. So you might lose your consciousness, but your body is up and down, so your diaphragm is moving up and down. Yes, you are inhaling and you are exhaling, right? So that is breathing. So when I say breathing, so that includes both inspiration as well as expiration. So normally when a person is breathing, that is your tidal volume, right? So everyone is breathing, so we take in some amount of oxygen and we give out some amount of carbon dioxide. That is the normal level, right? So this is your tidal volume. Clear? Yes. So tidal volume is the normal tide, okay? The up and down tides of your beach. Clear? So tidal volume is the normal tidal wave that is present. Clear? Yes. So this is the volume of air that you inspire or expire during a normal respiration. So here it is not anything abnormal, here and this is not anything extra. This is the normal level. Okay, so here a normal level that you can breathe in, you can breathe out is 500 ml. Okay, so at a time if you are taking in 500 ml of oxygen and say you give out 500 ml of carbon dioxide. Okay, so per minute how many times you repeat this? 6000 to 8000 ml of air you are using. Either you are expiring, either you are inhaling. So this is your tidal volume. Okay, yes ma'am, a very happy good evening. So thank you for joining my lecture. So please do like, share and subscribe. So Shimpi says she is not breathing. So because you have cold, is that so? If you do not breathe, then you will not survive because your body will not have oxygen, right? So if there is no oxygen, then it will not produce any ATP. Why they measure air in liter but we won't measure air in liter? No, we are measuring air in ml. Okay, so I am measuring air in ml. I am not measuring in liter. So that is too much of air, right? So here I am adding 250 ml of water, but here the capacity is in liters. Always the capacity should be more. Suppose if it is a beaker which can accommodate only 250 ml of water, but I am trying to fit 1 liter, that is not possible, right? So always capacity is more and capacity is measured in liters, but volume is less, so volume is measured in ml here. Okay, yes? Yes, you breathe through your mouth. Yes, Shimpi. Okay, fine. So tidal volume is the normal volume. So you say you give out 500, ma'am, where we use tidal volume? Yes, hold on. So normally all of us have tidal volume. Say we give out 500 ml of oxygen, carbon dioxide and take in 500 ml of oxygen. So per minute we use 6000 to 8000 ml of air. Okay, so air has a mixture of both, right? So this is the condition. So this is the total amount. So this includes both inspiration and expiration. So this is the total volume that you will inhale or exhale in a normal condition. So whenever the term normal respiration comes, it refers to your tidal volume. Okay, yes. So the value is 6000 to 8000 ml per minute. Okay, then what is this 500 ml? Say 500 ml you expire and 500 ml you inspire. Okay, this is during one time of breathing. So per minute you use 6000 to 8000 ml of air. Alright, the next one is inspiratory reserve volume. Sometimes, okay, so your favorite food is made. Say for example, your mom made dosa. Okay, so dosa is your favorite, so you tend to have 4 dosas. But sometimes your mom says eat one more. So sometimes the dosa is very crispy, very tasty that you want to eat one more, right? But suppose if my level is 3 dosa and if you can normally eat 4 dosa, but you feel like eating a little more on an extra day. Sometimes my normal level is 3 dosa, but I eat 4 one day and you take 6 because it is very tasty. So this differs, right? Yes? Okay, so he is giving me Hyderabadi biryani. Okay. So normally say you take 2 servings of biryani, but it is damn tasty that you take 4 servings, right? So you take some extra because you have space, you want to eat. So similarly, when you have more of oxygen, more of fresh air, so your body tries to inhale more. Okay, the value is fixed, it is not fixed, but the range is fixed. The range is fixed. So for example, my tidal volume can be 5500, but your tidal volume can be 7500. The range is fixed, the value is not fixed. Okay, so sometimes people, depending upon their physiological condition, depending on other conditions, they take in extra air. Okay, the extra that you inspire apart from your additional breathing. So normal amount you have taken. So Hyderabadi biryani you have taken 2 servings. Extra you want to take 1 more serving. So that is your reserve. That is extra. Okay. So whichever extra amount you have at home, you put it inside the bank, right? So that is reserving. That is saving. So inspiratory reserve volume. Apart from your normal breathing, how much extra air you can take in. So that is your inspiratory reserve volume. So this is your IRV. additional volume of air inspired by forcible inspiration. So normal respiration is tidal volume. Apart from that, how much extra you take in, that is your inspiratory reserve volume. So this can be 2500 to 3000 ml. So the total is 8000. The total range is 6000 to 8000, right? So if you can take in additional, it should be half of inspiration, half of expiration, right? So this includes both your inspiration and expiration, right? So here half will be inspiration, half will be expiration. So the extra is this value, okay? Done? So the next one is expiratory reserve volume. Sometimes you have so much of carbon dioxide accumulated, or yes, you have a little more carbon dioxide in excess compared to your normal respiration. So you give out more carbon dioxide. Okay. So this is additional volume of air expired in addition to the normal breathing. So you breathe normally, but extra when you expire. So this is your expiratory reserve volume. So this will be half of inspiratory reserve volume if you see. Okay. So tidal volume is total inspiratory plus expiratory. So half of the tidal volume will be your inspiratory reserve volume if you are smart enough. Then half of this will be your expiratory reserve volume, because you cannot give out all the air. You need some amount inside. You cannot expire everything outside, right? So the amount you inhale should be greater than the amount you exhale. So because at one point you cannot stop breathing, right? So you are breathing continuously. So the inspiratory reserve volume should be more. Okay, so now let me explain. So I have used all the blank slides I had. No problem. Okay, let's use here. So now the entire amount is tidal volume, right? So this is your normal respiration. So normal respiration includes your inspiration plus expiration. Okay. So normally you inspire 500 ml approx and you expire 500 ml. So in a minute, so you use 6000 to 8000 ml. So this is per minute. Okay. So whatever extra you inhale, so that is your inspiratory reserve volume. So this is extra whatever you inspire. So this is in addition to this. This is tidal volume extra to this. Okay. Yes. Theory to remember the trick. Alright, okay. So whichever you feel comfortable, yes, you can remember. Okay. So tidal volume, expiratory, residual. Yes, you're absolutely right. Yes, that's also a perfect trick. Okay. So this is extra, the amount that you inspire extra. So this will be half of this. So take half of 6000, so that is 3000. So this is 2500 to 3000. Okay. So this is inspiratory reserve. The next one is expiratory reserve volume, the amount of air that you give out extra, that is you exhale extra in addition to your tidal volume. So this is half of this. So this is 1100 to 1200 ml. Clear? So this is the biggest volume because this is normal respiration. So half of this is inspiratory reserve volume, half of this is expiratory reserve volume. It is very simple. So normal you should know, that is tidal volume. Okay. So normal range, so remember only this 6000 to 8000. So half of this is inspiratory reserve volume, so say 3000. Half of this is expiratory, say 1500. So yes, it can approximate to 1500 as well. Okay, Bhavna, isn't this easy? Yes, this is done. So we are done with 3 volumes. You have one last volume, that is residual volume. So what is this residual volume? So here we go, let's talk about the residual volume. Here we go. Volume of air remaining in the lungs even after a forceful expiration, that is 1100 to 1200 ml. Okay, so this is the same value I gave for this, so don't worry. So now a person is breathing normally, but he is trying to exhale extra, right? So remember, your tidal volume is the maximum amount and half of this is inspiratory volume, and your expiratory volume is half of this, which means you already have more amount of air inside your body, right? Like I told you, you cannot stop breathing for a moment. Your breathing has to continue even after you forcefully exhale, right? You do like this, no? Sometimes you are like you are doing yoga. So even after you forcefully pull out everything, but you do not have the capacity to empty your lungs, always some amount of air remains inside your lungs. So that is your residual volume. So volume of air remaining in the lungs even after a forcible expiration, even after you try to throw out all the air, some amount remains inside your lungs. So this is your residual volume. So whatever you try to exhale, the same amount is present, because half of this is this, right? So the remaining half is still present inside your lungs, right? So your inspiratory reserve volume, half is expiratory, half is residual. So how many of you got this concept right? So are you understanding the logic behind? Yes? Are you understanding the logic behind? Yes, is this clear? Is this clear to everyone? Yes? Yes, any doubts? So Bhuvana, you understood what is residual volume? Shimpi? Yes, Dharni, are you watching? Anthony? This is clear? So inspiratory volume is 3000, right? So 1500 is what you give out and 1500 is what remains inside. See, you are inspiring extra, right? So residual volume is the amount that remains inside your lungs. So you are forcefully expiring. Even then, all the air inside your lungs will not come out, okay? So like I told you, you cannot stop breathing for a minute. You have to continuously breathe. Though you forcefully expire, you cannot empty your lungs. Always some amount of air is present in your lungs. So that is residual volume. Suppose you take in more oxygen. So you take in more oxygen, say for example, you take in 3000 ml extra, okay? Then you try to give out carbon dioxide, okay? So you can give out only 1500 ml of carbon dioxide, okay? Yes, you exhale this. So some amount is remaining inside, right? So this is the another half. So this is the residual volume, okay? So which means only half of the oxygen has reached the tissues and the remaining half is still inside the alveoli, okay? So this is your residual volume. Clear guys? So I have defined 4 definitions of volume. So 4 volume definition is done. Tidal volume, inspiratory reserve volume, expiratory reserve volume and residual volume. So now moving on to capacity. So capacity is the ability of your lungs, right? So now we are talking about your lungs. Inspiratory capacity, though you can normally breathe and you can breathe in extra, but how much your lungs can accommodate. So that is your inspiratory capacity. So this is the normal inspiration plus the amount you inspire extra. So tidal volume is normal. So this is the amount you take in extra. So this is the capacity of your lungs for taking in air. So inspiratory capacity is tidal volume plus IRV. Okay, the total volume of air a person can inspire after a normal expiration. So this is normal inspiration plus the extra. Okay, so TV plus IRV. Alright. So then you have expiratory capacity. So this is total volume of air a person can expire after normal expiration. But how much your lung can support expiration? For expiration, your diaphragm has to relax, everything happens, right? So how much is your expiratory capacity of your lungs? Is the normal expiration plus the extra that you can do. So inspiratory capacity is the normal inspiration plus the extra. So expiratory capacity is the normal plus extra, right? Yes, so this is clear. So always you have formula for capacity, not for volume. Done? Okay. So this is the first part. So now talking about the second part. Yes, hold on with this question. I will come back to this question. So now further, you have what is known as functional residual capacity. Hello, hi Shivananda. Yes, thank you so much for joining my session. So please do like, share and subscribe. Okay, so you are giving love from India. Okay, well even I am in India. So I am in Kuta, Rajasthan right now. So love from Career Point as well. Okay, so functional residual capacity. So we spoke about residual volume. That is the ability of the lungs to hold volume of air inside. Yes, your lungs cannot be empty. If your balloon is completely empty, it will burst, right? So your alveoli can never be empty, right? It always holds up some residue. So what is the capacity to hold that residual volume? So that is known as functional residual capacity. Okay, so volume of air that will remain in your lungs after normal expiration. So this is nothing but your residual volume, right? So this is your how much extra you can give out and how much is remaining. So this is your functional residual capacity. How much residual volume your air can hold. So you forcefully expire everything, but even then some amount is kept inside. Right? Yes, and that is ERV plus residual volume. So this is the residual capacity of your lungs. Alright? The next one is vital capacity. So the term vital means important. Right? The important capacity, the maximum volume of air a person can breathe in after a normal expiration or after a forced expiration. So now, yes, so a person has tidal volume, that is normal breathing, but he tries to exhale extra, that is expiratory reserve volume. Now, what is the capacity that your lungs can hold, or what is the capacity that is needed for the lungs? So, you have both inspiration and expiration, but you try to expire extra, but the lungs will hold on to what is essential, right? Yes. So, suppose if I am distributing food, but at the end of the day, I make sure at least I have one plate of biryani for me, and then I will distribute everything, right? So what is that vital capacity of the lungs? Only then I can distribute. So if I have 100 packets of biryani, yes, I can give 99 packets, but that one is essential for me. Similarly, though your lungs can exhale as much as it wants, some amount is very, very important. That is vital capacity. Okay. So this is your tidal volume plus your inspiratory reserve volume plus your expiratory reserve volume. So your vital capacity, the capacity that your lungs has, okay, for its survival is that it can accommodate the normal breathing plus the extra expiration plus the extra inspiration. So this is the capacity. Okay, this is the most important capacity of the lungs. This is total lung capacity. So this is needed for every person's survival. But as such, how much the lung can hold? Suppose if I am going to buy a container, I say my container should hold 100 liters. That is my need, right? But as such, the container can hold 1000 liters. So that is the total capacity. But the one that I need for my survival is vital capacity. Okay? So total lung capacity, the total volume of air accommodated in the lungs at the end. So what is the total volume? So you have tidal volume also. So you have inspiratory reserve volume also. You have expiratory reserve volume also. Plus you have residual volume also. So all the volume makes up the total capacity. So we read 4 definitions of volume. All the definitions of volume make up your capacity. That is your total capacity. Okay? Yes. So why here I have written VC? Because this is vital capacity, right? So this is vital capacity plus RV. So this is another way of writing it. So did you guys understand? Yes? Yes, did you guys understand this? Is this clear? No doubt? Sab clear? Yes, Bhuvana, yes, Shimpi. So did you understand the 4 capacities ka definition? Yes, Pooja says yes, very good. So you will never make mistake. Okay? So here we go. So volumes have no formula, capacities have formula. So what are the capacities we read? Inspiratory capacity. So this is equal to the normal respiration plus the extra inspiration. So we have expiratory capacity. So this is normal expiration plus extra, right? Then we have functional residual capacity. How much residual volume your lung can hold? So this is your expiratory reserve volume plus your residual volume. Then you have vital capacity. So vital capacity is IR, inspiratory reserve volume plus expiratory reserve volume plus your tidal volume. Okay? So this is important. Okay? At least if your residue is not present, at least it should have the normal breathing. Okay? Then the last one is your total lung capacity. So this is vital capacity plus your residual volume. So now the definitions are clear to you? Yes? The same thing is shown in the form of a graph. So you have values only for volume. So you need to remember only 4 values because we have only 4 volumes here. Yes, is this clear everyone? No doubt. So never you should make a mistake in this. So now shall we solve those 2 questions? Yes? Yes, I have a question for you. Lungs are made up of air-filled sacs. Okay? So these air-filled sacs are your alveoli. Okay? So they do not collapse even after forceful expiration because of what? So lungs always have some amount of air left. That is what I told you. So the same question is being asked, why doesn't your alveoli collapse? Because it is a balloon-like structure. So it is air filled. So forcefully, even if you take out all the air, your alveoli does not collapse. Is it because of expiratory reserve volume or inspiratory reserve volume, residual volume or tidal volume? Yes, what is the answer? Yes, Antonia B, you are absolutely right. Yes, so this is because of some amount of volume that is always present inside your air. So this is inside your lungs. So this is your residual volume. Yes, absolutely perfect. Okay, great. So shall I go to the next question? Yes, yes, Pooja, absolutely right. So question number 2. So lungs do not collapse after between breaths and some air always remain in the lungs which can never be expelled. So this is talking about alveoli. Okay, so that is why you have volume. So this is talking about your lungs. So this is some capacity. So there is a positive intrapleural pressure, there is a negative intrapleural pressure pulling at the lung wall, there is a negative pressure in the lungs, the pressure in the lungs is higher there in the atmospheric pressure. Yes? So when I am talking only about tidal volume, so I continuously inhale and I continuously exhale. So approximately the same amount, right? So, but in between these two, even if I have a millisecond gap, my lungs do not collapse. Why so? Yes, so ultimately because your alveoli do not collapse because it has residual volume. I agree. But here, with respect to the 4 options given, what will be your answer? What will be your answer? There is positive intrapleural pressure. No, there is always a pressure at the lung wall. There is always a negative pressure at the lung wall that ensures that your lungs do not collapse. Okay, so see, if there is always some pressure acting, it will hold it rigid, right? It will not collapse. So, there is always some pressure at the lung wall that prevents it from collapsing. So, imagine I have a tent. Yes, so I am holding the four corners of the tent with the help of bamboo sticks. So there is pressure in the corners. The moment I pull off the corner, so what happens? It is not going to collapse, right? It is perfect. So that is how it is. So that is the reason there is always some pressure that is present at the walls. Now you get, Pooja? Yes, is it clear? Now you understood? Your doubt is clarified? So, are the doubts clear about respiratory volumes and respiratory capacities? Yes? Yes, clear? Yes, there is a negative gradient. Okay, I am not saying pressure gradient, but there is a gradient. Alright? Yes, clear? Okay, fine. So with this I stop. In the next lecture I will finish off this chapter because this is the most tricky part of the lecture. After this chapter is pretty easy. Okay. So thank you so much for joining my lecture, but don't forget to join me tomorrow at 4 p.m. So I am explaining the process of translation and human genome project. And at 6 p.m. we have a motivational session entitled Good Things Always Take Time to Happen. So please join me for both the sessions tomorrow, and I promise not to disappoint you. But don't forget, a gentle reminder, think about the crash course. Alright, so this is me wishing you more and more. So thank you so much for joining my lecture. So have a great night ahead. Stay tuned and take care. Bye.